It will always look impossible until you do it. We have a special Newton's law question for special people, and we are given that Elena pushes the block at an angle of 19.9 degrees with an applied force of 44.13 newtons. The block reaches point P at a speed of the speed at point P here, the initial velocity there. The initial velocity is 1.45 meters per second, and the distance d is traveled at in 0.5 seconds. This is the time, and as we are asked to determine the kinetic frictional to define the kinetic frictional force. So before we define it, we are given the coefficient of kinetic frictional force there to be 0.1. Yes, we can start by defining kinetic frictional force, and we all know that kinetic frictional force is the force that opposes the motion of a moving object relative to the surface. Always is relative to the surface. So since this block is going upwards like this, kinetic frictional force will oppose the motion. That's how we define kinetic frictional force. And now we are supposed to draw the free body diagram of this block. So we represent the block with a dot like this, and then we can start with a normal force. Let's start with normal force. What is normal force? Normal force is a force that is acting perpendicular to the surface. So which one is the surface? This is the surface. Perpendicular, it means normal force will be acting in that direction. And then we know that weight is going directly downwards. This is weight, or Fg. And then now we have the applied force that is applied at this angle like this. This is the applied force, which is 44.13 newtons. This is the applied force. And then from here, what else are we having? We are having the frictional force, the kinetic frictional force. We're having the kinetic frictional force, Fk here. Fk, we have the Fk there. And then what else are we having? So these are the forces that are acting on the block. So now we are asked to calculate the magnitude of kinetic frictional force. How do we calculate it? We know that kinetic frictional force is equals to normal force times mu k, or the other way around, same thing. So it means we must start by determining normal force. So in this case, what is our normal force? Normal force is equal to all the forces that are going exactly this side. And what are those forces? It means we have to break down the applied force into vertical and horizontal components. We have to break it down into vertical and horizontal components. And what happens if we break it down? We're going to have Fx this side, and we're going to have Fy. So it means that normal force is equal to all the forces that are going to the opposite direction. So it means this force is equal to this force. Why? Because there's no left and right movement. So it means this force is equal to this force. So it means in this case, normal force is equals to F at x. And how to calculate F at x is F sine theta. And what is F? We are given to be 44.31 sine 19.9, which is the angle. And then normal force will be equal to 15.02 newtons. But as we're not looking for normal force, we're looking for kinetic frictional force, which is given by the normal force, which is 15.02, and the coefficient, which is 0.1 there. And then the kinetic frictional force there is equal to how much? 1.50 newtons. So this is how we get the kinetic frictional force. And then now the next question is asking us to calculate the length of the window, which is given by the distance d. My question is, will you be able to find it? If you are still struggling, don't forget you can rise as well with Maths and Science Connect. And you can let me know how much you're getting for the distance d, given the velocity, the time, and you are looking for the distance.